Hello friends, this video on application of integrals part 1 is brought to you by examfear.com. No more fear from exam. What we will study? We will study introduction, we will study area under simple curves. For example, you have this curve and you have to find the area between this curve and the x-axis. We will study how to find the area between two curves. You have this curve, curve 1, curve 2 fx gx, the two functions, two curves actually, and we have to find the area between two curves. So these kind of two problems we'll study in this chapter. Area under simple curve, this is widely used in the terms in the physics world where you have some curve and you find the area. That time we use this. And the concept is pretty simple. You have this y is equal to fx function, correct? So what you do is you take a small strip of dx length and width y. So the area of this rectangle will be how much? Y into dx, correct? And please note the y varies. If you take this strip here, the y is different. If you take this strip here, the y is different, right? So if you take different strips, the value of y is different, and y is nothing but fx. So you can say nothing but fx dx for this strip. Now you have so many strips, right? You keep changing the value of x from a to b, you get so many strips. So you do integration from a to b, and that is what you get. If you see, the area is nothing but integration of dA. This guy is dA, small area, and this guy is nothing but y into dx. You take y, a rectangle whose length is y and width is dx, and y is nothing but fx dx. Now this is one area, small area of this rectangle, but you want to find the complete area. So you will take all the small rectangles you get from here to here, here to here, all the rectangles you'll add, and for that you are saying my x is varying from a to b, and that's what you get. You vary x from a to b, fx dx, that is the area. The same thing if you're asked to find the area of this curve with respect to, let's say, the y-axis. In this case, for example, you have this curve and you want to find with respect to y-axis, same concept here. In this case, it will be x into dy. The area of, if you see, the dA is nothing but x dy, area of the small chunk. And similarly, you have so many small chunks, right? So many small chunks. So x is variable, x at any point of time is nothing but gy. So you can say this is nothing but gy into dy. This is the small area, and the complete area is nothing but the integration of this from where y changes from d to c, and that is what you get, correct? So you chase, you have this x dy is a small strip area dA, and then you integrate this from where y varies from here. Please note, in this case my x is varying, and in this case my y is variable. Please note, here x is variable and here y is variable. So y varies from d to c, correct? If you see, c to d you can say, because c is less than d, c to d. Anyway, we always talk about the absolute area. We'll talk about this. So because area can't be negative, so even if you give negative value here, you have to take the positive part of that. So that's how it is. So you, in this case, the y is varying from c to d. In this case, my x is varying from a to b. So if you see, x is varying from a to b, and that's how we calculate the area. This is the basic concept actually. So hope you understand this. What I'm doing is, I have this curve. In this curve, I want to find the area. So what I have done is, in the first case, I wanted to find the area of this curve with respect to x-axis, where x is varying from a to b. I get this area. So this area I'm saying here nothing but y into dx, because I take this small rectangle y and this is dx. You get dA, that is small area, the one pink side. You want to find the whole thing. That means you have to integrate this where x is varying from a to b. Similarly, in this case, you find the small area, the pink one, that is x dy, that is gy dy, and you want to find the whole thing. Then you have to integrate this where y is varying from c to d, and the area has to be absolute. Why I told you, for example, in this case, if you find the value of this guy, it will come out to be negative. This values will come out to be negative, correct? Why? Because if you see, your x is positive and y is negative. Correct. So x into y will give you negative value. But since area has to be positive, so I talk about area is always absolute. Basic concept, when you talk about area has to be absolute, right? So whatever value you get, let's suppose fx dx you take the absolute value, or if you are integrating with respect to y, it will be gy dy, you take the absolute value. Correct? That's how you get. You may get complex figures, for example in this case where you see the curve is changing path, so some part is positive, some part is negative. In that case what you have to do is to find the point where it breaks. You can find this area, this guy is a1, this guy is a2. Then when you have to find total area, you can't say a1 plus a2, you have to say mod of a1 plus mod of a2. Why? Because area is always positive, so you have to take the mod value, absolute value of this guy, absolute value of this guy, and then add. So when you are adding areas, please make sure that you are adding the absolute values only. Don't add the negative part. Even if it is negative, you make it positive and then add. Because mathematically, this guy is negative and this guy is positive, right? So if you add this, it will be a subtraction actually. So, but we actually want to do operation, that is addition. So we will do a mod operation, mod a1, mod a2. Now let's see the examples to understand the concept which we have learned now. The first example is going to find the area enclosed by a circle. X square plus y square is equal to a square. So this is my circle with center 0, 0 and radius a. So I have drawn this circle. I have to find the area enclosed by this. There is the whole area, not the one in the pink, the whole area, right? If you see, the circle actually divides this into 4 equal halves. So all the 4s are equal actually. So you can say that area of circle is nothing but 4 into area of shaded region. Correct? We can say this. Why? Because if you see this guy, is nothing but 1/4 of the circle, because it's all equal quadrant by symmetry. Now we have to find the area of shaded region. Area of shaded region, you can see this curve is nothing but x square plus y square is equal to a square. So if I am trying to find in dx form where y is variable, so this guy is y dx. So if you see, I can write area of circle nothing but 4 into area of shaded region is nothing but integration of y dot dx. Correct? Please pay attention here, because I have my y strip here, dx strip here, right? And dx is varying and x is varying from 0 to a. Please note, this guy is 0 and this guy is a x component. So x is varying from 0 to a. This will be my area of shaded region, y dx 0 to a. Hope you understand this, why I am done this. Because I am in this case I am saying dx is varying. In the next example I'll solve the same question with dy varying, y varying. So now in this case it will be y dot dx, because at a given point you have this area as y, the pink one is y into dx, area of this rectangle. Correct? So you say y dot dx and you say x, because dx is very small and x varies from 0 to a. Now to solve this I have to write y in terms of x. If my x square plus y square is equal to a square, I get y square is nothing but a square minus x square, or y is nothing but root of a square minus x square. It will be plus minus, but anyway I have to take the absolute value itself, so I'm not bothered about the signs. Whatever it comes, I'll take the absolute value. So this becomes y, right, 0 to a, y becomes root of a square minus x square dx. Now let's integrate this. So 4 is anyway common, so this becomes s by 2 root a square minus x square plus a square by 2 sine inverse x by a, and x varies from 0 to a. Correct? So this becomes, you put x equal to a, this becomes a by 2 root a square minus a square, that is 0, plus a square by 2 sine inverse a by a minus 0, this becomes 0, minus a square by 2 sine inverse 0. This also becomes 0, and this guy is also 0, right? A square minus a square. So what you get is 4 into a square by 2 sine inverse 1, that is pi by 2. So we solve this, 2 become 4 cancel, this becomes pi a square, and that is my answer. And we know that the area of circle is pi r square. Here r is equal to a. So this means that the answer which we have got is correct. Correct. So what we have done here, we have divided this into 4 equal halves, and then I found the area of this shaded region. I told that the area of this region is nothing but y dot dx, because in this case I am taking a what you call vertical strips where the area is y dot dx for a rectangle. And then I told the area of the whole red thing is nothing but y dot dx, where integration where x varies from 0 to 0. Let's solve the same question in the other way where my y is varying. Here also same thing. Area of circle is nothing but 4 into area of shaded region. Correct. So what is the area of shaded region? In this case it will be x dot dy. X dot dy will be the area of this strip, right? And where y is varying from again 0 to a. So 0 to a is my y variable. Now again I have to write x in terms of y. So x is nothing but, if you see in this from equation form I get, x square is a square minus y square. So x is nothing but root a square minus y square. So let's put the same values here. So this becomes, I'll write here only 4 integration of root a square minus y square dy from 0 to a. Correct. So this, if you solve, this becomes y by 2 root a square minus y square plus a square by 2 sine inverse y by a, and this y varies from 0 to a. So if you solve the values, you get same answer actually. This becomes a by 2 root a square minus a square plus a square by 2 sine inverse a by a minus, this becomes 0, and this becomes a square by 2 sine inverse 0. So this guy is 0, this guy is 0, and this guy is also 0, a square minus a square. So what you get is 4 into a square by 2, correct, into sine inverse 1 is pi by 2, and there is nothing but pi a square, and that is my answer. So you get the same answer in both the case. You solve the question by making y variable or x variable, you get the same answer. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.